In this video, we will solve a system of linear equations by using the addition method. Now, in order to use the addition method and for it to do what we want it to, which is to cancel out a set of variables, we need to first ensure that one of our set of variables has opposite coefficients. So we can take a look here and we can do this in a few different ways. We could either make our coefficients on our x variables, the -3 and the -6, cancel, or we could take a look at our y variables, the -4 and the -1, and make those opposite. Either one works, and whichever one you kind of see first or makes more sense to you, do that one. I'm going to start with just using the canceling out the x variables. So we see we have a -6 and a -3. I could keep this one a -6 and make this a +6, and that would in turn make them opposite numbers and then cancel. So in order to make this a +6, I need to multiply the entire equation by -2. So that gives me a 6x plus 8y equals 4. So everything got multiplied by -2, so we distributed that. Then the second equation remains unchanged. And then here comes the addition part. We add them together. So the 6 and the -6 end up with 0 because they cancel out, and that's what we want to happen. The +8y and the -1 8y become +7y. And then 4 and -11 become -7. So now we have the simple linear equation to solve. Need to solve for y, divide by 7, divide by 7, and we get y is -1. Okay, from here we now can take that -1 and we can plug it in to either equation to get our x variable. Remember, we want to plug them into the original equations. Generally, I just pick the first one there, plug it in right into that y spot. So I get -3x minus 4 times -1 equals -2. -3x plus 4, -4 times -1 equals -2. Then let's get our numbers there together and leave the variables on the left side. Our constants, so we want to subtract 4 from both sides. And we get -3x equals -6, or x is equal to +2. So there we have our coordinate, which is 2, -1. And we do always want to check our answer by plugging in that 2 and that -1 to both equations.